Six Sigma, critical to quality. Now we're going to talk about critical to quality, often abbreviated as CTQ. CTQs are a key part of Lean Six Sigma because they connect customer expectations to measurable process or product requirements. In the define phase, we talked about voice of the customer. VOC helps us understand what the customer wants, needs, or expects. CTQs take that customer language and translate it into measurable requirements. This is important because we cannot improve quality in a meaningful way unless we know what quality means from the customer's perspective. In this section, we'll look at what CTQs are, how they appear in manufacturing, how they differ from internal metrics, how they connect to process capability, and how they are used throughout DMAIC. Critical to quality, or CTQ. CTQs are measurable product or process characteristics that must be met to satisfy the customer. They define what acceptable means from the customer's perspective. If a CTQ is missed, the output is considered a defect. That last point is important. A CTQ is not just something we prefer or something that would be nice to have. It is a requirement tied directly to customer acceptance. For example, if a customer requires a shaft diameter to be within a certain tolerance, and the shaft falls outside that tolerance, then the part is defective even if the rest of the process looked good. CTQs give us a clear standard. They help remove ambiguity from quality discussions. Instead of saying, the customer wants a good part, we define what good means in measurable terms. CTQ in manufacturing terms. In manufacturing, CTQs often show up as very specific product or process requirements. These may include dimensional tolerances, performance requirements, reliability or durability limits, visual or cosmetic standards, and delivery or lead time commitments. For example, a dimensional CTQ might be a whole location tolerance. A performance CTQ might be a required torque, pressure, speed, or load capacity. A reliability CTQ might define how long the product must last under certain conditions. A visual CTQ might define acceptable paint color, surface finish, scratches, dents, or cosmetic appearance. A delivery CTQ might define required lead time or on-time delivery performance. The key point is that CTQs are requirements manufacturing cannot violate without affecting customer acceptance. If we fail to meet a CTQ, the customer may reject the product, experience a failure, lose confidence, or face problems in their own process. From customer need to CTQ. Now let's look at how we translate customer needs into CTQs. A customer might say, the part must fit correctly every time. That is a valid customer need, but it is not specific enough for manufacturing or quality control. To make that need usable, we translate it into engineering-level specifications. For example, the CTQs might be, shaft diameter must be 25.000 millimeters plus or minus 0.010 millimeters. Roundness must be less than or equal to 0.02 millimeters. Surface finish must be less than or equal to RA 1.6 micrometers. Now the customer need has been translated into measurable requirements. This is the bridge between customer language and process control. The customer may not use terms like roundness, surface finish, or tolerance stack-up, but those technical requirements may be what determine whether the customer's need is met. As green belts, part of our job is to help make that translation clear. CTQ versus internal metrics. It is important to understand that not every metric is a CTQ. Some metrics are very important internally, but they are not directly customer-facing. For example, machine uptime is important. If uptime is poor, it can affect productivity, delivery, cost, and scheduling. But machine uptime itself is usually not a CTQ because the customer does not directly experience machine uptime. Scrap rate is also important. A high scrap rate can increase cost, reduce capacity, and indicate process problems. But scrap rate is usually a business or process metric, not a direct customer requirement. On the other hand, whole location tolerance can be a CTQ because it directly affects whether the part assembles correctly. Cosmetic color variation can be a CTQ if the customer has defined visual expectations or appearance requirements. A useful test is this. If the customer would not notice the metric failing, it is probably not a CTQ. That does not mean internal metrics are unimportant. They are very important for managing the business and improving the process. But we should be clear about which metrics are customer requirements and which metrics are internal performance indicators. CTQ versus internal metrics table. This table gives us a practical comparison. Machine uptime at 95% is not a CTQ. It matters internally, but the customer does not directly experience it. Scrap rate at 3% is also not usually a CTQ. It is a business metric. It tells us something about cost, yield, and process performance, but it is not directly customer-facing. Hole location within plus or minus 0.25 millimeters is a CTQ because it directly affects assembly. Cycle time less than or equal to 30 seconds may be a CTQ sometimes. If the customer requires delivery speed, responsiveness, or a defined lead time, then cycle time or delivery time may become critical to quality. Paint color variation less than or equal to delta E 1.0 is a CTQ because it affects perceived quality. The takeaway is that CTQs are defined by customer impact. We should not assume a metric is a CTQ just because we track it. We need to ask whether it connects directly to customer acceptance, fit, function, safety, reliability, appearance, or delivery. CTQs and process capability. CTQs are also important because they define the specification limits used in process capability analysis. When we calculate capability, we are asking whether the process can consistently meet the CTQ requirements. Two common capability metrics are CP and CPK. CP is potential capability. It measures whether the process variation is small enough compared to the specification width, assuming the process is perfectly centered. In other words, CP tells us whether the process spread could fit inside the customer's specification limits. But CP does not tell us whether the process is actually centered. That is where CPK comes in. CPK is actual capability with centering. It accounts for how close the process mean is to either specification limit. If the process is off-center, CPK will be lower than CP. In day-to-day quality discussions, when people say capability, they often mean CPK because it gives a more realistic picture of whether the process is actually meeting the requirement consistently. Capability answers a very important question. Can the process meet CTQ requirements consistently? As a rule of thumb, a CPK around 1.00 is borderline. The process spread roughly equals the specification width, and defects should be expected over time. A CPK around 1.33 is a common minimum requirement in many industries and supplier quality systems. A CPK of 1.67 or higher is often used for critical characteristics or high reliability expectations. Exact requirements vary by customer, product, and industry, but the concept is the same. A low CPK is not just a process issue. It is a customer risk. If the process cannot consistently meet the CTQ, then the customer may eventually receive defects. CTQs and DMAIC. CTQs play a role across the entire DMAIC project. In the define phase, we identify CTQs from the voice of the customer. This helps us understand what matters most to the customer. In the measure phase, we collect data on CTQ performance. We establish the current baseline and determine how the process is performing today. In the analyze phase, we identify sources of CTQ variation. We look for the factors that cause the CTQ to miss requirements or drift toward defects. In the improve phase, we reduce CTQ defects, reduce variation, or shift the process mean closer to target. In the control phase, we monitor CTQs using tools like SPC, control charts, control plans, standard work, and reaction plans. This is why CTQs are so important. They keep the project connected to customer impact from beginning to end. Without CTQs, a project can drift toward internal preferences or convenient metrics. With CTQs, the project stays focused on what the customer actually needs. Is it a CTQ? Quick test. When you are trying to decide whether something is a CTQ, ask 3 questions. First, would the customer notice if this went out of specification? Second, does it affect fit, function, safety, reliability, or delivery? Third, is there a defined acceptance limit? If the answer is yes to all 3, then it is likely a CTQ. For example, if a part dimension affects assembly and has a defined tolerance, that is a CTQ. If a cosmetic requirement affects customer acceptance and has a defined color or finish standard, that is a CTQ. If a delivery requirement is part of the customer expectation or contract, that can also be a CTQ. This quick test helps separate true customer requirements from internal process measures. Again, internal measures still matter. But CTQs deserve special attention because they define what the customer considers acceptable. To summarize, CTQs are measurable requirements that define quality from the customer's perspective. They translate customer needs into specifications. They help us distinguish customer-facing requirements from internal performance metrics. They define the specification limits used in capability analysis. And they guide the project through every phase of DMAIC. As we move forward, keep CTQs in mind as the link between the customer's voice and the process performance we need to deliver.